Jim, here at Bowman Additive Production, you're manufacturing real life parts on your HP printers. Now, can you give me some examples of the parts that you're manufacturing?
Well, we've put our money where our mouth is. We're a bearing company, so we make our own bearing cages like this for roller bearings. Now, what we've been able to do with this is make something that you can't machine. The reason we've done that is you can put more bearings rollers in. So for the same size of bearing, you get 70% more load or 5 times the life. And by adding in the end races like this, you actually get a roller bearing that can take end thrust. In fact, 1,000% more end thrust than any other bearing on the market, which is quite an achievement that can only be done with additive manufacturing.
So have you patented these designs?
13 patents and counting.
Are you re-engineering components using additive manufacturing technology? So not just these components here at Bowman?
Yeah, we like to add value into everything that we do. We can take a simple part such as this very simple flanged bushing. Now, you would never in a million years additively print that unless you wanted one at a really odd size and nobody could be bothered to turn it. But when you start adding in on each of these corners a chamfer and a chamfered hole all the way through and an oil way, becomes more expensive. You'd probably still machine that. However, if you would take something which is as light as you can make it, just as strong as it has to be, it takes a lot of design. And this part here, you would never in a million years machine that because it would take too long. And the ridiculous thing about additive manufacturing is this solid one here is twice the price of that complicated one there. Complicated is not only free, it's cheaper. And you can only add the complication if you understand additive manufacturing.
So additive manufacturing now, Jim, has been around for a long time. People are coming to terms with it, are using it, but majority of people are still using it for R&D and prototyping. What you're saying is really, Jim, you need to be thinking out of the box, and you can actually use this technology now for real life applications, and you're re-engineering components that have historically been made in a certain way with the technology that's been available at that given time.
Yeah, I'm an old dirty fingernail engineer from Rolls-Royce, so you know I spent many years winding handles in anger and creating swarf. Let's take, for example, something really simple like this, a very simple needle roller bearing cage. You would have to be very careful with the standard materials for this if you wanted to wrap it over a shaft. This one, we can fold it flat, doesn't matter. And we can bang these out thousands at a time in the machine, and it's also a shape that you can't injection mould.
Now with that particular component there, I mean, it kind of illustrates in a way the tolerances that you're holding to be able to incorporate the roller bearings.
Well, yeah, a lot of additive manufacturing, in inverted commas, is done by people who make models. Now those models are great, they can be fit, form and function, but the buzzwords that we always use are verifiable, traceable, accurate, repeatable. We can verify the machine, we can verify the materials back to source, and we can verify each build, when it was built, the strength of the parts in it, the accuracy of the parts in it. To give you an example, our scanner looks like something you can buy for £1,000. It was actually 40 grand, and it costs us 13,000 a year just for the software to run it. But having done that, because we are making critical parts for ourselves, which have to be accurate, repeatable, verifiable and traceable, we should be able to do that for other people as well, which is how we've done it.
The materials that you are printing in are obviously suitable for the applications that you're using them for. However, you know, for people that are looking to get into this arena and produce components that they were historically making out of steels, what would you say to them? Because isn't that still a bit of a barrier?
Questions are, do you need the strength of steel? The most horrible question you can ask any designer is, why are you making it like that? If he says, well, we've always made it like that, then you can go, right, sit down, what are the forces involved, where is the loading, and we will be honest and we'll actually tell you if we can't help you. Most of the time we can. Let's take something which you'd see anywhere. That's a tiny little linear bearing, which was originally machined, the casing was machined from perspex, because they've always been machined from perspex. Now we've managed to make a bearing with a semi-spherical hole in it, so it lubricates better, it rolls better, and these are not very expensive at all, and you can't ejection mould it.
I mean, it is phenomenal, really, the kind of applications and examples you've got here. Can you just finalise, really, and summarise with this propeller?
Well, this impeller is an idea that we've got for, I can't tell you who it's for, however, the impeller that they're using is on a battery operated craft. Now battery operated anything is all about weight and efficiency. The impeller they're using at the moment is the most efficient shape they've got with traditional machining. What we've done is we've gone to them and said, what do you want it to do? Well, we'd like it to shift X amount of water for X amount of watts of power, but we can't machine one that shape. We can.
I mean, you've illustrated to me today some of the brilliant examples of what you're actually manufacturing for real life applications. Now, do you believe, I can tell you're really excited, you must believe, is there a big future in additive manufacturing, and where's it going to go from here?
Additive manufacturing has got to have several things happen. First, we've got to educate for additive manufacturing. I get a bit evangelical about it because 30 odd years ago when I was in old school engineering, I would have given my left arm for one of these, as you would have probably done when you were on the tools. We're not educating people for additive manufacturing. People are a little bit stuck in their ways, and I can understand why, because if you've got, you know, several £1 million worth of 5-axis machines out there, you don't want somebody who can come and make something like this with one engineering manufacturing process, and that is press go.